Well, one of the ways in which we can test our understanding is by answering questions of the nature called what if questions. And so let me illustrate that with this CMOS inverter. It's a basic building block of digital circuits. And there are several important properties of this CMOS inverter. One of them is the let's say the voltage transfer characteristics. So let's write it down, voltage transfer characteristics. We call it VTC in short, and from there we get noise margins, NMH, NML, all these things that are there here. And we also calculate a quantity called inverter threshold voltage to see how symmetrical the characteristics are. So voltage transfer characteristics are one of the important characteristics of the inverter. The other one is the delay, and we define it, let's say, in terms of propagation delay, high to low, propagation delay, low to high, maybe rise time, fall time, and things like that. The third thing is power dissipation. So that's there would be static power dissipation, dynamic power dissipation, so all of that is there. And let me add a fourth one, which is always important, which is related to the cost, basically related to the area of the physical area on chip occupied by this particular inverter. So I've listed these four characteristics that are there here: voltage transfer characteristics, delay, power dissipation, and cost. And so if you think that you understand the inverter, CMOS inverter very well, then you should be able to answer questions where if we make modification in certain part of the inverter, you should be able to answer what its impact will be on each one of these four parameters. So as an example, suppose we take the size of NMOS. So let's look at the first one, size of NMOS. Say size of NMOS is doubled, meaning that new W by L1 dash is, let's say, twice of W by L1. Whatever is the size right now, suppose the size is doubled, right? Now what we would like to know is, well, can you tell what would be the impact on voltage transfer characteristics? What would be the impact on delay, the components of delay? What would be the impact on power dissipation? What would be impact on area perhaps? So if you can do that, then that would be a good test of your understanding, that you understand the CMOS inverter quite well, that you can predict that if you change something in the CMOS circuit, CMOS structure of the inverter, then you can tell what would be the consequences of that particular change. Another one is, let's say VDD, suppose this VDD is 3 volt, and we change VDD to 3.5 volt, right? What would be the impact? So, the question is, what if we increase VDD? So the question is, what if we increase VDD? What would happen, right? So what would happen again is in terms of its impact on voltage transfer characteristics, its impact on delay, its impact on power dissipation, and things like that. And there are more of such changes that we can think of. For example, besides the what if the size of, so here we can frame the question, what if size of NMOS is doubled? And then there could be a question like this here. So for example, if we take a CMOS inverter, what if a resistance R is added to source of NMOS? Again, what will be its impact on voltage transfer characteristics, delay, power, and all of that here? So see if you can answer this particular question. Again, this is a question of what if a resistance R is added at the input. right? So in each one of these cases, what we are doing is we are asking a what if question. What if a certain change is made to the circuit? Can you predict what the impact of those particular changes are? And impact in a comprehensive manner on all aspects of the inverter, right? So as we have indicated, voltage transfer characteristics, delay, participation, cost, all of those things here. So that's a good way of testing whether you understand the circuit in a deep manner and you understand the consequences of any changes that are made in that particular circuit, how they would impact.